This is 2022 R1, and this has to do with drop gables and let-in gables heel plating in particular. One of the things that has been a problem for quite some time is the heel plating that we've had in previous releases, and we have always needed to make adjustments to that in almost all cases on submitted designs and send back modified files to customers for just about everything. Not quite, but just about. And so it was time, without a doubt, to fix that. So in R1, we have changed the plating at the heels for drop gables and let-in gables from what it used to be to what we really need it to be, for the most part at least. So if I run this if I run this truss, you'll see that we're now getting a standard plating, which is a 3x4 at the heel and a 3x6 rotated over the three members. And I'm going to go through some of the technical stuff as to what this is doing and show you what the issue is and what the issues might be going forward, and also talk about this a little bit more. The idea here is that these trusses, drop gables and let-in gables, if they're designed on the R1 version, should be more acceptable. I wouldn't say in 100% of the time. There's going to maybe be some exceptions, but most of the time we should not have to modify these any longer and send back modified files. So this greatly cleans up the results here for the comp review team, and will help save us time and save customers frustration, and should help us reduce the number of modified files going back to customers. Okay, so the way that we're plating this is, this plate is centered along the scarf line here, between here and here. So the center of the plate is the center there, and it's an automatic 3x4 minimum plate size. If the forces are required to be higher than that, then it will bump that up. Previously, the rotated plate was a non-structural wedge plate. That caused some issues because it didn't always get placed correctly. So now these two plates together make up the plating for the heel. This is now a structural plate, and it is not a wedge plate, and it's not non-structural. And this plate is placed by calculation. It's near the center of the scarf length along here, but more importantly, it is placed so that the areas here on all three members are the same, okay? And we can do that by some simple geometric calculations to get the areas to be placed the same. So basically what we're doing here is we are taking the force that's in the top chord member. We're designing both of these plates to handle that force times a factor, and then we're also checking, of course, the bottom chord. So all three members get checked. There is a factor that's used here because we did not think that it was appropriate to consider 50% of the force being handled by each plate. We think that both of these are doing some of the same job. In other words, the force is coming, if we follow a load path, the force is coming down through this lower top chord member. It's going to transfer through this plate back up into the top chord, okay, into the upper top chord. And then this heel plate is going to have to handle all of that force as well to transfer it back into the bottom chord. Now there is some force that gets transferred through the bottom chord to the bottom chord through this inside plate. But we don't think that it's 50-50. It's from the testing and from some of the things that we've looked at, it's not 50-50. So we have created an environment setting to control this. And again, it's in the model limits, and it's right here. Percent of axial force required for each plate. And we have that defaulted to 75%. So we can set it to as low as 50 on a given situation if we need to, and we can set it as high as 100%. And basically what that means is this is for each plate. So in other words, when we look at, let's run this again. When we look at these heel plates, this plate is designed for 75% of the forces of the top chord force. This plate is designed for 75% of the top chord force. So the combination of the two of them are designed for really 150% of the force, okay? Now that's on top of all other factors that get applied. That includes the pitch factor and everything else that gets applied to a heel, okay? And whatever lumbar factors and orientation of the plate factors and all of that. So just keep that in mind, and that's for the shear and the tension and the gripping areas are all controlled by that percent of force that's being handled. Okay, so let's look at the plating calcs here just quickly. I'm going to go to select this, and you'll see that it will be labeled with the inner heel plate, excuse me, and the external heel plate. So the inner heel plate is shown first here in this case. I think it depends on where you click, but that doesn't matter. The inner heel plate, if you look at the forces that are being plated for here, it will be 75% of these forces that are shown up here as the maximum plating forces, okay? So in case you're wondering about that, and you'll see here that the required area and the actual areas are the same in this case. It's really the actual areas that I wanted to point out, though. We're getting 6 square inches on all 3 members based on where we're placing this plate, okay? And then the calculations are being done for all 3 members here. We've got 2 shear lines here, and both of those are shown, okay? If I scroll this on down a little bit to the second plate, you will see that we're getting the outer heel plate, okay? Again, it's got the same force here, which is 75% of the total, okay? And you'll see that as it's placed here, in this case, you get 6 square inches on both members. It's half and half, okay? Always oriented parallel to the bottom chord, and this one's always oriented perpendicular to the bottom chord and placed such that all of the areas are the same. So basically we've got 6 square inches here, 6 square inches here, 6, 6, and 6 square inches on each of the members here. And all of that all put together handles the plating for this condition. You'll notice that the do not notch note has been moved down to be at the inside of wherever this plate ends up being located, okay? And then the tie plates start from here and go 2 foot on center, going uphill from there. So the tie plate placement is a little bit different than it was before. And on previous versions, because this was treated as really a slider, there was a slider plate here that was placed right in this area. That is now gone, okay? It's not necessary. A lot of times we would change that into just another tie plate anyway, but then it would fail because the program still saw it as a slider plate, and we would have to override that. We no longer have to do that, okay? So in general, that kind of covers it here. You can look at some standard conditions. Oh, the final thing that I wanted to say here, and I made this clear in the webinar that we had about this topic already, is that this is not versioned. So existing trusses, even if you have a truss that's fairly old, let's go all the way back to 2020.1. If I run that, I'm going to get the same new plating here that is required for the R1, okay? So what that means is existing trusses that are out there are going to automatically adapt this new plating and other changes. For the most part, if they were trusses that we fixed and sent back as modified files, they should still work. If they don't, it's quite fine to have the customer ask us if they need to have it approved as we had sealed it before. Just let us know and we'll take a look at it and make sure it's not too far off. and we'll go ahead and do that. If there are other issues or other reasons why that existing plating didn't work, then we would want to go with whatever the new answer is, okay? And note that there could be some minor lumber changes as well, and it could go either way. In some cases, the truss could work better. In other cases, it could work a little bit worse. So if you get any of those, and if it's possible, the best bet is to just rerun that truss with the whole lumber and hold plates unchecked, and just let R1 redesign that completely and get the new lumber and the new plating, okay? And for any new trusses going forward, we're going to get the right answer. So I just wanted to make that clear. Existing trusses, because we always had to change them anyway, they are not protected by this change. But any new trusses will be fine, and if we need to on existing trusses, just let us know and we'll take a look at it and see if we can approve it again. We would prefer that everybody updates and gets the quote unquote more correct answer here. And finally, I just wanted to mention there are maybe still some conditions. We wanted to hit like the 95% mark of all of the reasons why we have to change and create modified files because of this. And that was our focus here. It's still not 100% perfect. There could be some situations where it doesn't plate correctly, and we need to do some modifications there. So we will be keeping an eye on it, and there could still be some modified files coming back with drop gables and let-in gables, but it should be very minimal compared to what we were doing in the past. Again, like with everything, if you have any questions on this, please let me know.